Hello, math students. This is Module 1, and we are working with ratios and unit rates. The lesson for today is actually Lesson 6, and it's called Tables of Equivalent Ratios and Ratio Table Structure. Our goal for today is, we are going to learn what a ratio table is and how to work it. The question that I want you to think about during our lesson is, what is represented on a ratio table? Okay, things to learn. We're going to start off with a task. The teacher wants to make paper mache for masks in art. She mixes water and flour. For every 2 cups of water, she needs 3 cups of flour. So what is the ratio relationship? And it actually already tells you right there in the task. For every 2 cups of water, she needs 3 cups of flour. So that, remember our ratio relationship language, there's your for every right there. And it doesn't have there are, but she needs could be the substitute for that. So the ratio relationship is 2 cups of water. For every 2 cups of water, she needs 3 cups of flour. Okay, list 4 equivalent ratios to the ratio from the task. So I actually am going to use a tape, and it says that she needs 2 cups of water for every 3 cups of flour. So I'm going to say this is water and this is flour. And then if we had the exact one that it said, then it would be 2 to 3. But then if we were making equivalent ratios, I could have this same table, but this time instead of it be ones in there, because remember we're doing a review. If they were ones, then it would be 1, 2. So that's 2, 1, 2, 3, 3. But what if they were 2's in here? So 2, 4, and then it would be 2, 4, 6. What if they were 3's in here? 3, 6, 3, 6, 9. What if it was 4's in there? 4, 8, 4, 8, 12. Okay, did we make, oh, not yet. I have to do one more because it's 4 equivalent ratios to the ratio from the task. This is the one from the task, so we have to do one more. So let's do 5. 5, 10, 5, 10, 15. So do you see how using the tape is a really helpful method to help us organize it so that we can pay attention to what we're doing? All right, so there's the 4 equivalent ratios from the task. How could you organize the equivalent ratios? Well, one of the ways that we can do is we can list them like this, or we can also use a table. Okay, is there a model that could help us? The model was the tape, so I'll just draw it again, tape diagram. That wasn't so horrible, so we could use a tape diagram as our model, which we did. All right, and now let's look at this next page, and we're going to talk about a table. The table that I was referencing is actually called a ratio table, and the ratio table is a way to organize and show equivalent ratios. The independent value goes on the left side, and the dependent value goes on the right side. And the reason why that is the case is because the left side is the input side, so we put a number in, we do something to it, and it shoots out an output. So this is the output. And the reason why we call this the input side and this the output side is because you put a number on this side, you do something to it, and it changes it into this one. Okay? So it says, remember what you do to one side, you have to do to the other. So if we use our example from the tape diagram that we did, we put 2 in, and 3 came out, right? Then we changed it so that each tape was worth 2, so we put 4 in, and 6 came out. Then we put 6 in, and 9 came out. Okay, so that's what we're talking about putting them in and something coming out, because we changed it. What you do to one side, you have to do to the other. All right, so now it says, let's make a ratio table for the paper mache relationship, which we kind of just did. So for every 2 cups of water, there's 3 cups of flour. So when we have 4 cups of water, we have to have 6 cups of flour because we already figured it out. When we have 6 cups of flour, we need 6 cups of water, we need 9 cups of flour. And when we have 8 cups of water, we need 12 cups of flour. And it says off to your right, what do you notice about the values? Well, if you look, this one and this one have been doubled, right? Does everybody see it? Then you go back to the original. To get this answer, they were tripled. Then go back to the original. To get this one, they were quadrupled. Okay, so 2 times 2 is 4. 3 times 2 is 6. That's doubled. Okay, so this line tells us that they were doubled. Okay, this line tells us that they were tripled. And this line tells us that they were quadrupled. Okay, so that's kind of fun. All right, so now it says ratio tables use the multiplicative property when comparing columns. So when you're going from the input side to the output side, it's multiplicative because you're multiplying it. Okay, so notice this is what multiplicative means. We took every number in the input side and we multiplied it by 5. So you take 2 times 5 and you get 10. You take 3 times 5 and you get 15. You take 4 times 5 and you get 20. You take 5 times 5 and you get 25. And you take 6 times 5 and you get 30. So the fact that we use the same amount on each number, that means that it's multiplicative. So ratio tables use multiplicative property when they compare the columns. And so test it and see if it worked. 2 times 5 equals 10. 3 times 5 equals 15. 4 times 5 equals 20. 5 times 5 equals 25. And 6 times 5 equals 30. So it's multiplicative because every value on the input side was multiplied by 5, and it gave us the output answer. Okay, so that's multiplicative. All right. Okay, so then the next thing that we're going to talk about is ratio tables are using the additive property when it comes to comparing rows. So when you're doing columns, these are columns, this is a column, and this is a column, it's multiplicative. But when you're comparing row by row, it's additive. Okay, and so let's talk about it. To get from 2 to 3, we added 1. To get from 3 to 4, we added 1. To get from 4 to 5, we added 1. And to get from 5 to 6, we added 1. Well, when we went from 2 to 3 and added 1, we actually did 10 to 15, which is added 5. 15 to 20 is added 5. 20 to 25 is added 5. 25 to 30 is added 5. Now, this is a ratio table that works because it followed the rules. If I add one more and I say this one is 7 and this one is 36, then to get from 6 to 7, we added 1, but to get from 30 to 36, we had to add 6. So the reason I'm showing you this is that if this ever happens to you, you know this answer is wrong. Okay? And the reason why you know it's wrong is because it has to follow the pattern. If you add 1, add 1, add 1, add 1, add 1, the only thing you can add on this side in the rows is 1. If you add 1, add 1, add 1, add 1, add 1, and you add 5, add 5, add 5, add 5, add, this has to be an add 5. So as you can see, this is where the mistake is. This is called a mathematical error by self. This is a good way to check and see if you made an error, because if your pattern does not follow the pattern, and remember, this is only when you're comparing rows. If it doesn't follow the pattern when you're comparing rows, it is not a real ratio table. Okay, because a ratio table, when it's additive, it has to have the same addings on both sides, or the same pattern. So add 1 is on this side, add 5 is on this side, so that means there was a mistake, and you have to go back and fix it. Okay, so kind of cool. Rows, it's called additive. Columns, It's called multiplicative, okay? When we're looking at this, we doubled, then we tripled, then we quadrupled. The ratio table has an input and an output. The input is the x, which is the independent variable. The output is the y, which is the dependent variable. The reason why it's dependent is you can't get this answer without having this one and doing something to it. Okay, so y depends on x. Using tape diagrams to help us figure out equivalent ratios. Holy moly, we did a lot in this lesson. Today we are going to learn what a ratio table is and how to work it. I think we did. I think that we did a good job. And what is represented in ratio tables, that's the answer that I need to see either in your notes, option 1 right there, or in option 2 in questions and answers for Mrs. Nelson. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.